So now we want to get back to prime and composite numbers. So let's give a definition to what a prime number is. All right, so we'll go here. Excuse me. A prime number is any number that has only two factors or smaller parts of it, or numbers that are multiplied to create it. And we'll talk further about that. Let me give an example of a prime number, 2. If you were to multiply two whole numbers together to form this, you would get 2. 1 times 2. There are no other whole numbers that can be multiplied to equal 2. Any? Didn't think so. So at that point we just stop. This is a prime number. Remember, it has two factors. The number itself and 1. See? 1 times 2, that situation. So that's a prime number. It is a number that has only two factors, the number itself and 1. So let's talk about composite numbers. Composite number, let me give you an example of composite number 4. Let's talk about why this is a composite number. The reason why it's a composite number is because it has more than two factors. Now you notice here, like I did on the example with 24, we had different ways we get 24. 2 times 12. We had 3 times 8. We had 4 times 6. Well, you can sort of use that same idea if you wanted to figure out if a number is composite. We know that 2 times 2 will give us 4. We also know that 1 times 4 will give us, well, that's not really a prime number, so I shouldn't circle that. I shouldn't circle neither one of these. 1 is neither prime nor composite. It's one of those interesting digits, so go here. So we'll go here. And where was I? So we have 1 times 4. You can see in this situation we have more than two factors that make it up. Let's talk about them. We have the 1, so that's your first factor. We have 4. It's your second factor. Notice 1 times 4, 4. We have 2 times 2 here, but because these are two of the same numbers, it's only the third. But that third makes it a composite. Why? Because a composite number has more than two factors. Notice, prime numbers, 2 factors. The actual number you see and 1. Another prime number, 3. An additional one, 5. Why? 1 times 3, can't go any further. 1 times 5, can't go any further. Now let's take a look at composite numbers. I'll give you an example with 4. Let's get some other numbers. Give you examples of. I'm going to erase this. We'll go 4, 8, and then we'll do 12. We've already given you everything for 4. You know that has 3 factors. So let's try the 8. Two times 4. 1 times 8. At that point, I can already tell the number is composite because 2 times 4, first factor, second factor. 1 times 8, third factor, fourth factor. This thing definitely has more than 2 factors, as we can see here. 2 times 4, first factor. The 4, second factor. 1 times 8, third factor, 1, fourth factor, 8. So we can see in this situation that this is a composite number. Let's extend this out. Actually, I'm going to leave this here. Let's look at the 12. And we get, let's put this here. So with the 12, 2 times 6, 4 times 3, and 1 times 12. Definitely a composite number. You can stop right here. 1, 2, 3, 4, 5, 6. It has 6 factors. 2 times 6, 4 times 3, 1 times 12. So you can see why these numbers are composite. They definitely have more than two factors. You can see why these numbers are prime, because they have two factors only. I'm going to end this video talking about prime and composite numbers, and then we're going to jump right into prime factorization.